All right, we are going to continue on with chapter six today, the second part of chapter six. Last time we focused mainly on the z-score aspect of the normal distribution or bell curve. Today, we're actually going to learn about how to find different probabilities and solve different types of problems using the normal distribution. So, let's get started. First thing we want to talk about is this thing called the 68, 95, 99.7 rule. You may have learned about this in Algebra 1 or Integrated 1, depending on what class you took. But basically, what this says is that if we have a normal distribution, if we know that a set of data is normally distributed, meaning it's unimodal and it's symmetric, that approximately about 68% of the data, of the values, is going to be within one standard deviation of the mean. So that means it could be anywhere between one standard deviation below to one standard deviation above. So about 68% of the values will fall within one standard deviation of the mean. Okay. The 95 stands for 95%. So about 95% of the data is going to be within two standard deviations of the mean. And you could probably guess what the next number is for. All right, approximately 99.7% of the values will fall within three standard deviations of the mean. So that's kind of a general rule of thumb when it comes to normal distribution or normal models. And the reason this rule is important is this is what we would use to find normal percentages when we didn't have technology. Obviously, we have technology available to us today. So this rule is not as important. You do still need to know it. You still need to know that 68% goes with one standard deviation, 95% with two, 99.7% with three. But it is not as important because instead of using this rule, we're actually going to use StatCrunch to help us find all those hard answers. Okay. Here's kind of a visual picture of what you'll see, what I talked about on the previous slide. You can see we have a bell curve, a normal model that is unimodal and symmetric, and you can see the mean is in the middle. Okay, remember I talked about the other day, this mu here is that's the Greek letter, the symbol for mean. And you can see it shows that 68% of the data is between one below and one above, one standard deviation above the mean. And we have 95% and then 99.7%. So this is just a kind of a visual representation of what I talked about on the previous slide. Okay. Now, like I said, we're not going to use that rule. We are going to use StatCrunch. Remember, I talked about this a couple chapters ago. StatCrunch, you go to statcrunch.com, okay, and you sign in with the same username and password that you use for MathXL. And when you do that, you click on Open StatCrunch, and we'll take you to a spreadsheet. And we're going to use the normal calculator function. So on StatCrunch, you're going to click on Stat, then you're going to go to Calculators, and then you're going to go to Normal, and you're going to get something that looks like this. Right? And this is what we're going to use to solve all of the problems in this section of Chapter 6. So to show you how it works, here's an example that I stole from the textbook. So we have the mean height of Dutch men is 184 centimeters, and the standard deviation is 8 centimeters. What percent of Dutch men should be less than 190 centimeters tall? So again, I go to, on StatCrunch, I go to Stat, I go to Calculators, and I go to Normal. Okay, and when I get that, this comes up. Okay, and you'll notice Okay, you'll notice I put in the mean where it says mean, so 184. This is a screenshot of what I did on my computer. I put in the standard deviation of 8. And then down here, okay, where I have that arrow, that is a drop-down menu. And the drop-down, in that drop-down menu, can either choose the less than or greater than or equal to. Now, in this particular case, I chose less than or equal to because the question said what percent of Dutchmen should be less than 190 centimeters tall. So in this drop down menu, I put in less than, whoops, and then I typed in 190 because we want to know what percent is less than 190. And when I hit compute, I got an answer. Whoops, I got an answer down here. All right, and it gives the answer as a decimal. So you can see, based on that answer, we can say that about 77.3% or less than 190 centimeters tall. It's literally as simple as that. You put the numbers in and then just make sure you choose the right direction, less than or greater than, depending on what the question asks. Okay, here's another example. All right, same mean and standard deviation. What percent should be over 198 centimeters tall? So again, I go to stat, I go to calculators, and I click on, and I go to normal. And notice this time I put in the mean, I put in the mean, I put in the standard deviation, but notice my mouse is getting in, that's getting in the way down there. Notice that in that drop down menu, I chose greater than instead of less than because we are asking what percent should be over 198 centimeters tall. So I typed in 198 and I got that answer down here. And so that comes out to approximately 4%. 0.04 is 4%. So what percent should be over 198 centimeters tall? Approximately 4% of Dutchmen are over 198 centimeters tall, based on this calculator here. Okay. Here's another example, another final example with this information. See, what percent of Dutchmen should be between 170 and 180 centimeters tall? So this one's a little different. Okay, it's not asking what percent or less or what percent should be greater. Now they want to know what percent should be between. Okay, so on this particular one, when I go to the normal calculators, stat, calculators, and normal, what I have to do is, because it's asking the percent that is within a range, I have to click on that tab that says between, okay, for obvious reasons. And when I click on the tab that says between, notice this comes up down here. So I can type in between 170 and 180. Obviously, also putting in the mean and the standard deviation. So the only difference this time is because we are finding the percentage within a range, in this case between 170 and 180, I have to choose that tab that says between. Okay. And we can see we get an answer of about 26%, a little more than 26%. So approximately 26.8% of Dutchmen are between 170 and 180 centimeters tall. Okay, so it's very simple. All right, we either use this one where we have to choose between less than or greater than, or if we're finding the percentage within a range, we choose the tab that says between, so we can put both those numbers in. Okay, so that's kind of one type of example where you're actually figuring out a percentage or a probability based on the mean and the standard deviation. The question is, just like with z-scores, what happens if we want to go backwards? Okay, so again, using this Dutchmen example with our same mean and our same standard deviation, What if we start with a percentage? Okay, so how tall are the tallest 10% of all Dutch men? So in this particular case, the percentage is now given to us in the problem, which means that we're going to go backwards. We're still going to use this normal calculator here. Okay, we're still going to use the normal calculator. We're still going to go stat, calculators, and excuse me, and normal on StatCrunch. Okay, we're still going to put in our mean, as you can see here, and we're still going to put in our standard deviation. But look what happens here. Okay, I still chose greater than on that drop down because how tall are the tallest 10%? So that implies greater than. But notice I put the percentage after the equal sign. So when we're going backwards, when the percentage is stated in the problem, we put the percentage as a decimal, and it always goes after the equal sign. Notice I put 0.10. All right, 0.10 is 10%. And if I hit compute, it actually gives me the answer. It actually gives me the answer in the center right here. Okay, so that answer tells us how tall are the tallest 10%. So the tallest 10% of Dutch men are more than 194 centimeters tall. So when we're going backwards, we're still going to use the same menu, except we're going to put that percentage as a decimal after the equal sign. Okay. Same kind of concept here. How tall are the shortest 20% of all Dutch men? Okay, so notice this time I chose less than or equal to because the word shortest implies less than. And notice I put after the equal sign, I put 0.20, 20%. And when I hit compute, it gives me an answer of about 177, it looks like. So the shortest 20% of Dutchmen are less than 177.3 centimeters tall. Okay. Last example. Okay. How tall are the middle 50% of all Dutchmen? Okay. How tall are the middle 50% of all Dutchmen? Okay. Just like before, okay, because it's asking about the middle 50%, I have to click on that tab that says between. So for this one, I'm going to choose between because they ask for the middle 50%. And it gives me the same thing here that I saw before. So I'm going to choose the tab that says between, and notice I put 0.5 for 50% after the equal sign. And the cool thing about StatCrunch is if I hit compute, it gives me those numbers, gives me those answers. So it's between 178 and 189. So the middle 50% of Dutch men are between 178 and 189 centimeters tall. Okay. So again, no difference except I put the percentage after the equal sign, and in this case, I had to choose between. Okay. So to kind of sum up, all right, this kind of sums up how we do everything on StatCrunch. When the question is asking you to find the percentage, okay, when the question is asking you to find the percentage, we put that number, the number they give us here. We choose our drop down less than or greater than, or we go to between. Okay. If the percentage is stated in the problem, so if we're going backwards, we enter the percentage as a decimal after the equal sign, and we leave the middle one blank, just like I did here. Or in the case of if it's a range, if it's between, I leave the middle 2 blank. Okay, so this kind of sums up how we answer those questions. And basically your Math Excel assignment for this section of the chapter is just going to be a bunch of examples where you have to solve problems either this way or this way. So if you get confused, either come back to this video and go back to the section of the video where I'm going over those questions, or go back to the PowerPoint itself and you can see the screenshots, and hopefully that will help. All right, that is it for chapter 6.